11.6 areas of regular polygons. It's a little tricky at first, but once you get into the basic idea of the formula and where it comes from, pretty simple to work with. I'm going to start off with this video with a little conceptual understanding of polygons and how they're built and basic understanding of the formula. I'm going to start off with a couple points. I'm going to build a hexagon by rotating this other point around that point 60 degrees. 360 divided by 6 is 60, because then I can build a hexagon. So take this point, let's select all these, and I'm going to create some segments. That's our hexagon. Notice that center point is key for finding some different values. We call this the center of the polygon. This is a regular polygon. Let me go ahead and put this. This is called the radius, because if I were to put a circle around that, it's the radius of the circle. Notice it's the same all the way throughout. Now the apothem is a new term. Let me go ahead and zoom in on that word. The apothem is the distance from P to Q. That's the perpendicular distance to one of the sides. So if I take this point and this side and this point, and I make a perpendicular line, then this point right here defines where the apothem ends from the center of the polygon. Notice this is a right triangle, so let me go ahead and select this, which helps us to find the side length. In fact, this side length is cut into two equal pieces. So go ahead and draw what you see, and I'm going to label out some values that you need for your notes. Alright, so we have our central angle. That's the angle that connects two radii or radiuses of the polygon, two adjacent radii. That's this angle right here. Then we have the apothem, which is this distance right here. And we have the radius of the polygon, which corresponds to the circumscribed circle, which goes all the way around. Alright, so just some basic terminology to make sure you're understanding how to find the different parts of the polygon. Notice this is a regular pentagon. That means there's 5 sides. And we're supposed to find this, and it's inside circle F. Find each angle measure. A, F, B. Notice that's one of the central angles, and these angles are a division of 360, or from 360, and there's 5 equal angles. 360 divided by 5 is the same thing as dividing by 10 and multiplying by 2. Dividing by 10 is 36, multiplied by 2 is 72 degrees. All right, then we have AFG. Let me clean up my drawing. AFG. This angle is half of the central angle. Half of the central angle. So if this is the angle, half the central angle is 36 degrees. Then we're looking for GAF. GAF. Notice that's part of a right triangle with 36. We have 90 degrees, we have 36, and we have some angle over here. Well, that's just 90 minus 36, which is 54. Go ahead and pause the video, try these two problems, and see if you get the same thing as me. Alright, let me explain what I have, just in case you don't have the same thing. Center is just being identified from the drawing. P. PY, it says a radius, that's a radius. This is a radius, this is a radius, and this is a radius. Any of those would have worked. Then it says find an apothem. The only one that you have drawn is PQ. It has to be perpendicular to one of the sides from the center of the polygon. And then central angle. The one that we have written is XPQ, or excuse me, XPY. We also have XPW and PW, or WPZ and ZPY. Sounds like radio stations. Last question says let's find some angle values. XPY is 90 degrees because there's 360 divided into 4 even parts, 90. Notice if this is equal to this and this is 90, then this is 45 and this is 45. So both of these are 45. This is just a short explanation of where the formula for the area of a polygon comes from. And we'll talk more about this in class. I've got an activity for you to go through. But let's see if you can understand from what we have here. We have some triangle here that the polygon can be broken into regardless of the number of sides. Notice it's the side length times A divided by 2, A being the apothem. That's where we get the area of one triangle. Then it's multiplied by the number of sides because the number of sides corresponds to the number of triangles. Notice if I take N and S and group them, these are the same as the perimeter because the number of sides times the side length gives you the perimeter. That means that the formula for the area of a polygon is 1/2 the apothem times the perimeter. Go ahead and write this portion in your notes because you're going to need to reference it when doing some problems here in a minute. So here's the formula you need. Go ahead and draw this hexagon down, write the A, the S, and need to reference this. This is the preferred formula, but you could also use this formula, knowing that A is the apothem, P is the perimeter, and the perimeter is the same thing as N times S, the number of sides, times the side length. All right, in example number 2, we're asked to find the area of the covering. It says decorating it, ceramic tiles, regular octagon. So we have an octagon. So the formula for the area of an octagon or any regular perimeter polygon is 1/2 times A times P. The apothem is given, and that is, the apothem is not given. All we have is the radius. I'm just going to draw the triangle of one of the octagon pieces. Notice in this triangle we do not have the apothems, which is what we need for this formula, but we do have the side length of 15 and a radius of 19.6. Now we're going to have to draw out a triangle and find these values. So go ahead and draw what you see, and let's draw out a new triangle. Now I'm emphasizing different components or different pieces of this. Notice I'm just focused on one of the right triangles. This is the one I'm talking about. I have A, I have 15 divided by 2 because this little segment is broken up into 2 equal segments. And then I have 19.6. Now if I'm looking for the apothem, I can just plug this into the Pythagorean theorem because I have 2 values of a right triangle, and using the Pythagorean theorem I can find the third side. So 19.6 squared is equal to A squared plus 15 over 2 squared. I'm going to go ahead and simplify this with the calculator. Alright, show you a little progress of what I've got. Went ahead and just typed this in the calculator, got this and that one over there, subtracted those. Now I'm just going to square root my value here to find my A. I got A to be approximately 18.11. I'm going to leave this stored in the calculator because you do not need to round until the very end. Now that we have the apothem, sorry about the bell. Now that we have the apothem and we have a side length, we can plug it into our formula, remembering that the perimeter is N times S. So I'm going to do that over here. The apothem is stored in my calculator, so I'm going to leave that stored there, but I'm just going to write A for now. N is 8 because that's the number of sides, and the side length is 15. And then I'm just going to type this in by recalling this value right here. You could write it in the decimal. I just think it's cleaner to do it this way. 0.5 times the apothem times 8 times 15 is 1086.5 inches squared. On this example, things get a little trickier because we've got to use some trigonometry to find some values. We're asked to find the perimeter and area of a nonagon, nonagon being a 9-sided figure. I'm going to draw just this triangle, just the triangle that has the 4 and the 4 for the radiuses. Notice this is 4, because if I can find the area of one of these triangles, I just multiply by 9. Notice I have the apothem, or I got to find the apothem, and I need to find the side length, knowing that this is half the side length and this is half the side length, which means the side length is the total. Awesome. Now, it looks like right now we don't have many values to find A or S, but we do have the central angle, noticing that the central angle is 360 divided by 9. 360 divided by 9 is 40. That means that one of these angles is 20 degrees. That means I have a right triangle with 20 degrees and my apothem I'm looking for and my hypotenuse. That means I can use either SO, KA, or TOA. Now looking for the adjacent, or in this case the apothem, I'm going to use KA right here. So cosine of 20 degrees is equal to the adjacent, which I do not know the value of, over the hypotenuse, which is 4. Then I just multiply both sides by 4, and I get 4 cosine 20 degrees is equal to the apothem. In my calculator, I need to make sure that I'm in degree mode, because this is 20 degrees. And I just type in 4 cosine 20. And I get A roughly equal to 3.76. That's the apothem. Now, in order to find the area and the perimeter, I'm also going to have to know the side length, noting that the side length divided by 2 is equal to one of these segments. At this point, I could use trigonometry, or I could use the Pythagorean theorem with the hypotenuse in A. I think I'm going to choose to do that, knowing that 4 squared is equal to A squared, which is roughly 3.76, but I'm going to leave it stored in my calculator, so I'm going to write a plus the side length divided by 2 squared. Now you could come up with a different value for s over 2 and call this, I don't know, z or something else. It doesn't really matter. I just like keeping it this way though. Alright, so 16 squared minus my a squared value. I'm recalling this value in the calculator, and I get, and I'm going to square root that. I get s over 2 is approximately equal to 15.55. Once again, I'm leaving this stored in the calculator. I multiply by 2, and I got the side length approximately equal to 31.1. Now, I've got the side length, I've got the apothem. Now I can find the perimeter, and I can find the area. First, I'm going to find the perimeter because that's needed to find the area. Noting that the perimeter is the number of sides, in this case 9, times the side length, which is approximately 31.1. If I take this answer, I'm just going to recall it, multiply by 9. The perimeter is approximately equal to 279.94. And this is in just units. Now the area, on the other hand, is equal to 1/2 the apothem. Now the apothem I already found to be 3.76. And this gets multiplied by the perimeter, 279.94. So I take this value and multiply by the 3.76, and I get the area to be approximately 1052.57 units squared. Alright, go ahead and pause the video, try these problems 3 through 6, and then see if you get the same thing as me. Alright, number 3 was somewhat in-depth. I went ahead and drew out just the triangle that I need. Focus on these values, noticing that I have a right triangle right here. I've went ahead and solved for s over 2, and then I solved for s by square rooting and following the rules of algebra. Then the perimeter is the number of sides times the side length. The number of sides is 5. That's where I got the 5. Plugged in that's 9.33. Then I just typed in that value and got 46.64 units. Then the area is the half times the apothem times the perimeter. The apothem is given 6.5. I just took that, multiplied it by the perimeter in my calculator, and got 151.57 units squared. Number 4 is a little trickier because all you're given is the side length. But if you've got the side length, you can make this triangle right here where we have a side length of 7, we have the radius and the apothem. Now, the tricky part here is noticing the angle and then using some trigonometry to find out the apothem. Now, this is the central angle. The central angle, if there are 10 sides, is 360 divided by 10, which I found to be 36. Now, 36 needs to be split into 2 equal parts. That's what I did here by dividing by 2. So, I have a right triangle. On that right triangle, I have 18 degrees, I have the apothem, and I have the this side value over here, which is half of the 7, so 3.5. I use that to set up my trigonometry, knowing that this is the opposite and this is the adjacent. So I set up my tangent, because tangent is TOA, opposite is 3.5, and adjacent is A. And if I multiply both sides by A, then divide by tan 18, I get this when I type it in the calculator using degree mode. Now, it's asking for the perimeter and the apothem. The area. So the perimeter is just the number of sides times the side length, and that's just 10 times 7. And I got 70. The apothem times the perimeter times 1/2 is equal to the area, so it's equal to 377 units squared. I'm actually going to talk through this one as we go. Notice this is an equilateral triangle because it's a regular polygon. It's got 3 sides. So I need to split this right here so I can find this, noting that this was 60, now it's 30 when it's split in half. This is a 30, 60, 90 triangle. I need to find the side length, which is 5 root 3, using 30, 60, 90 triangles. That's 5 root 3, which means the side length is equal to 10 root 3. If I were looking for the perimeter, it's just the number of sides times the side length. The number of sides is 3, but the side length is 10 root 3. That means this is equal to 30 root 3 units. That's the perimeter. The area, on the other hand, is 1/2 times the apothem times the perimeter. The apothem in this case is 5. The perimeter in this case is 30 root 3. So I just do 30 divided by 2, which is 15, times 5, which is 50, plus 25, which is 75 root 3. And this is units squared. Obviously, on number 6, I said that the last one was special right triangles. That was a 30, 60, 90. Number 4 deals with a decagon. Nope, there's no special right triangles, 45, 45, 90, 30, 60, 90. And the pentagon, neither is a special right triangle. So that's it for the video.